Okay, so this is regarding example 2. I will explain that. Your x is normally distributed with mean equal to 120 and standard deviation equal to 30. Find the probability that x is between 120 and 135. So in order to find the probability, as I told previously, that you have to convert your x to z. So again, here what we are going to do, we are just converting our x to z by using 120 subtracted from the mean and dividing by standard deviation. So x minus mu divided by sigma, again 135 minus 120 divided by the standard deviation. So what will happen now? Your normal value is converted to standard normal value. So here the value is 0, and then x minus mu over sigma, this is the formula for z, and then 135, if we compute, we get it is equal to 0.5. Okay, I want to mention one thing. Whether you have here equal or you don't have, there is no effect because it is a continuous. So whether you have equal or no, you don't have the equal, it is same. Okay, now how do you find this probability? Like previously you did, you have to do the same thing. Use a standard normal table in order to find the probability of z is between 0 and 0.5. So it means find the area from the standard normal table where z, so what we know about standard normal table, that the z, the mean is equal to 0. So in the middle it's always 0 when you convert your x to z, so the middle value is always 0. You need to find the probability that your z is between 0 and 0.5. So between 0 and 0.5 is a positive number, so somewhere here we will say. So we want this probability, it means we want this area. If you go back to your standard normal table, you will see that here you have 0.5. What is the next digit here? It's not mentioned, so it means the next digit is 0, so you will take the first column, 0.00. So what is that answer? You just see the answer is 0.1915. Okay. If you are asked to find the solution in percentage, you just multiply this by 100, so you get 19.15% if you're asked. Okay, this is the first question. So remember that the value you get it directly from the table. It is the value when your z lies between 0 and any value of z. When z lies between any other number different than 0, in that case you cannot say whatever I'm getting here is the same value I will put here. So that we will see in next question. Find the probability when your x is more than 90. Okay, probability when x is more than 90. So we convert our x to z in similar way. I will not write in detail because already I wrote. So when you convert your x to z, this value 90 minus 120 divided by 30, you get -1. Between the decimal is 0, 0. Okay, so how you are going to find the probability for this? To find the probability for this, we will say that this is the standard normal curve. In the middle is always 0. We want the probability of z greater than -1.00. -1, it means the value of z is in the left side of 0, somewhere here, -1. Okay, now when we said find the probability that z is greater than this number, it means we want the right side area of z. Right side means the right side from -1 to 0 and the right side of 0. So what we know about standard normal curve, we know the total area is 1. And if we cut the curve into two parts, the right side part will be 0.5 and left side area will be 0.5. So if we said we want the area from -1 to this, it means we want the area from here to here, from -1 to 0. We can get it from the table. It is equal to 0.3413 plus we can get the area from here to the end. This area is equal to 0.5. Okay, so your final answer is equal to 0.8413. Okay, if you want to convert it into decimal, 84.13%. So remember that table only gives you the area from any value of x till 0. And one more thing, you should remember, whether your z is negative or +1, the area is always positive. It can't be taken as a negative because it's an area, it is a probability. Okay, so for the last question, find the probability that x is less than 145. Okay, so that probability x less than 145. So we are going to convert our x to z again. Z less than, if we convert 145 to a z value, we just subtract 145 minus 120 divided by 30, we get the answer as 0.83. So we will draw first. This is most important. You want the probability of z less than this number. So where is this number in the curve? In the middle we have 0 for standard normal curve. 0.83 is a positive number, so it is in the right side of 0, so 0.83 somewhere. If we said we want the probability of z less than this number, it means we want the probability of left side. So from 0 to 0.83 and including this area also. So what we know that? We know that the area from here to 0, it is 0.5. And the area from 0 to 0.83, if you use the table, it is equal to what? 0.2967. 0.2967. So the final answer is 0.7967. If you are asked to convert your answer in percentage, multiply it by 100, you get 79.67. Okay, so this is the second example solution. I hope it's clear to you. So we will see next